Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the problem, the fuel efficiency E in liters per 100 kilometers for a car driven at a speed V in kilometers per hour is E at V equals 1600 V over V square plus 6400. And we have to answer these three questions. So in part A, we have to find, so if the speed limit is 100 kilometers per hour, determine the legal speed that will maximize the fuel efficiency. So we are given this function E at V for fuel efficiency, and we have to find the value of V that will maximize fuel efficiency, or that will give us the maximum value for this E function. Now we are given that the speed limit is 100 kilometers per hour. So that means we can use this value to write the domain for this E function. So as per the given speed limit, so the value of V can be greater than equal to 0, because speed can either be 0 when the car is at rest, or a positive value, and the maximum value here is 100. So this is the interval for V in which we have to find the legal speed that will maximize the fuel efficiency. Now in order to find the maximum fuel efficiency, we'll have to find the derivative of the E function, because we'll have to find the points where the tangent is horizontal, because the tangent can be horizontal at the peaks in the graph of this efficiency function. So the first step is to find the prime of E at V. Now the given function E is a rational function, so we'll have to use quotient rule to find its derivative. So we start with the derivative of the numerator, so 1600V. So the derivative with respect to V will just be 1600 times the denominator, so V square plus 6400, then minus the numerator, which is 1600V, times the derivative of the denominator. So here we'll have to use the power rule, so it will be 2V plus 0. So 6400 is a constant, so that's why its derivative is equal to 0 divided by the square of the denominator. Now we can simplify the numerator expression. So prime of E at V. So in the numerator, we can distribute the 1600 into the parentheses. So we get 1600 V square plus, now we have to do 1600 times 6400, which is 10,240,000. Now in the second part, 2V plus 0 is just 2V. So we'll just multiply 2V by 1600V, which gives us negative 3200 V square over V square plus 6400 square. Now we should set this derivative equal to 0 to find the values of V where the tangent is horizontal. So we get 0 equals, and now we can simplify the numerator by combining like terms. So 1600 V square minus 3200 V square is equal to negative 1600 V square plus 10,240,000 over the denominator V square plus 6400 square. Now we can solve this equation So first we can cross multiply the denominator. So the left side becomes equal to 0 because 0 times any term is equal to 0. So negative 1600 v squared plus 10 240 0. Now we have to solve for v. So the next step is to add 1600 v squared to both sides to move the v term to the left side of this equation. So the 1600 v squared on the right side cancel each other out. So we get 1600 v squared equals 10,240,000. Now we have to divide both sides by 1600 because we want to isolate v squared. So the 1600s on the left side will cancel each other out and we get v squared equals 6400. Now we can apply square root to both sides. So on the left side, the square root and the square cancel each other out. So we get v equals 80. Now, because we are applying the square root, so we get plus minus 80. But since we cannot be a negative number because we only have to analyze the v values between 0 and 100, so the valid answer will be just positive 80. And the unit will be kilometers per hour. Now we have to find the maximum fuel efficiency. So for that, we'll analyze the three v values and calculate the efficiency values for these three speeds. So the first value is v equals 0, which is the lower limit of the interval. So we'll sub in v as 0 in the efficiency function to find the value of efficiency. So E at 0 will be equal to, so 1600 times 0 over 0 squared plus 6400. So since the numerator becomes equal to 0 and the denominator is not equal to 0, this whole fraction becomes equal to 0. Now we'll have to calculate the efficiency at the value we got from the derivative, which is 80. So v equals 80. So now we'll sub in v as 80 in the efficiency function. So E as 80 equals, so 1600 times 80 over 80 squared plus 6400. And now we can simplify this expression. So 1600 times 80 is equal to 128,000 over, now in the denominator we do 80 squared plus 6400, which is 128,000. So now we can simplify this expression. So E at 80 is equal to 10. Now we have to find the E value at 100, which is the upper limit for the V. So we can do the calculation here. So V equals 100. So E at 100 equals, so 1600 times 100 over, so 100 squared plus 6400. So E at 100 is equal to, so now we have to do in the numerator 1600 times 100, and that will be 160,000 over, now in the denominator we have to do 100 square plus 6400, which is equal to 16,400. So E at 100 is equal to, so 160,000 divided by 16,400. So we got 9.76. Now we can find the legal speed at which the fuel efficiency is maximum. So we have to compare these three values for efficiency at 80 and then at 100. So from these three values, we can see that we got the maximum value for E at 80 kilometers per hour, because then we got a value of 10. So here our final answer can be summarized as, so 80 kilometers per hour maximizes fuel efficiency. We don't have to write the value of fuel efficiency in the closing statement, because it's just asking for the legal speed that will maximize fuel efficiency. So this should be the final answer for part A. Now we can analyze part B. Now in part B, we have to find the speed intervals within the legal speed limit of 0 to 100 kilometers per hour in which the fuel efficiency is increasing. So if the fuel efficiency is increasing, that means the slope of the tangent at those speed intervals is positive. And we know the slope of the tangent is determined by the derivative of the function, in this case the fuel efficiency function E. So the first step here is to set the fuel efficiency derivative to greater than 0, because that means the slope of the tangent will be positive and therefore the fuel efficiency will increase in that interval. So the first step is, so I'll use a different color here. So negative 1600 V square plus 10,240,000. So here we are using expression for derivative of the E function, and V square plus 6400 square is greater than 0. So this is our first step. Now we can cross multiply the denominator. So we get negative 1600 V square plus 10,240,000 is greater than 0, because 0 times any term is equal to 0. Now we can move the 1600 V square to the right side and make it positive. So we'll add 1600 V square to both sides. So the 1600 V square on the left side will cancel each other out, and 10 million is greater than 1600 V square. Now we can divide both sides by 1600. So the 1600s on the right side will cancel each other out, and on the left side we'll get 6400 is greater than V squared. Now we can apply square root to both sides, change V squared to V. So we'll get, now here when we apply the square root, so we'll get the plus and the minus scenarios. But since the given interval for the speed is between 0 and 100, we'll only consider the positive case. So we'll just get 80 is greater than V, or the speed should be less than 80. Now since the given interval is from, or the interval that we found for V is from 0 to 100, so the final answer should be that V is greater than equal to 0 and less than 80, and this should be the final answer for part B. So this is the speed interval in which the fuel efficiency is increasing. Now we can analyze part C. So in part C, we have to determine the speed intervals within the legal speed limit of 0 to 100 kilometers per hour in which the fuel efficiency is decreasing. So the same idea as part B, but instead of setting the derivative to greater than 0, it should be less than 0. Because when the fuel efficiency is decreasing, the slope of tangent will be negative. So our first step is, so negative 1600 V square plus 10,240,000 over, so V square over 6400 square should be less than 0 because the fuel efficiency is decreasing, so the slope of the tangent should be negative. Now we can cross multiply the denominator, so we get negative 1600 V square plus 10,240,000 is less than 0. And now we can move the 1600 V square to the right side to make it positive. So we'll add 1600 V square to both sides. So the 1600 V square on the left side will cancel each other out. So we get 10,240,000 is less than 1600 V square. And now we can divide both sides by 1600. So the 1600 on the right side will cancel each other out and we get 6400 is less than V squared. Now we can apply square root to both sides. So on the right side, the square and the square root will cancel each other out. Now again, we'll get the plus and the minus case, but since the interval for V is greater than 0, we can ignore the negative case. So that means V is greater than 80. Now, since there is an upper limit for V, that means the speed interval in which the fuel efficiency is decreasing is, so V is greater than 80 but less than or equal to 100 kilometers per hour. So this should be the final answer for the speed interval in which the fuel efficiency is decreasing. So these are the steps you have to keep in mind to solve a problem like this one. So to find the maximum fuel efficiency, we have to set the derivative equal to 0 and then solve for the value of V and then use the interval bounds, the upper limit and lower limit to find at which V value the fuel efficiency is maximum. And for part B, we have to find where the V values for which the slope of the tangent is positive. And for part C, we have to find the V values for which the slope of the tangent is negative. So these are the steps you have to keep in mind to solve this type of problem. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.